and demand. Supply and demand. And something called equilibrium point. Not the break-even point, but the equilibrium point, EP. Supply and demand functions and the equilibrium point. What does that mean? Okay. So here is a demand function. Meaning, if the price is high, very few people can afford to purchase. When the price, so this is price per unit, units. So at this high price, only very few people can afford. But as the price decreases, more units can be sold or bought. This is a demand function. Now, the supply function is the opposite. It's an increasing curve. Why? Because suppliers at such a small price, they don't really want to provide or supply us. But as the price goes up, they are interested in selling more and more, but we're not willing to buy because the prices are too high. So this point where the demand function and the supply function cross is the EP, the equilibrium point, in which we are willing to purchase this number of units at this price per unit, and they are willing to supply. We are happy, the suppliers are happy, the producers are happy. This is something called the equilibrium point, where the demand and the supply cross. So let's take a look at an example like this one, and then move on. So this is not what I meant. I meant my page. Where is my page? Okay. So the data in the table. So right here we have supply and demand for unleaded premium gasoline. And here it is. But they are giving us the demand function and the supply function. As you see, the demand function, it's a linear function with a negative slope. It's decreasing. And the other one, which is the supply function, is a function with a positive slope, as expected. And they meet at the equilibrium point where everyone is happy. This number of units, this price per unit. Okay, so let's see. Let me copy the functions. I'm going to copy them as d of x because it's easier to understand what's happening here. Plus 4.5. And s of x, the supply function, 0.00075x plus 2.25. Okay, so let's see what they want. Of course, what they want is the equilibrium point. So let's see. Solve the system and find the equilibrium quantity and the equilibrium price for a gallon of unleaded premium gasoline. And then we have to fill in the information in part B. Okay, no problem. This is what we've been doing tonight, solving systems. So I said equal, of course, the demand function with the supply function to get the equilibrium point. So we set them equal to each other. So negative 0.00. So there were 2 zeros in there or 3 zeros in the first one. Let me double check. I only saw 2, but yes, 2 zeros. Okay, 15x plus 4.5 equals 0.00075x plus 2.25. Okay, so I'm going to move this here. and I have 3 zeros and 75. Negative 0.001. No, it's 2 and 25. X equals 2.25. So this is minus 2.25. Am I correct? I think so. So 4.5, correct. So therefore X equals 2.25 divided by 0.00225. We're going to check in a minute. So let me divide this. And we have, what do we have? We have 2.25 divided by oh, I didn't really need to use a calculator. Okay, 1,000. Yes, very easy. So X equals 1,000. In order to find the equilibrium point, we need 1,000, comma, it doesn't matter where we go back and plug it in. So let's say I'm going to plug it in here. So 1,000 would be negative 1.5 plus 4.5, which is 3. So, and I'm going to go back and check both in a minute. So what does this mean? It means that we're willing to purchase 1,000 units. 1,000 units at the price of $3 per unit. And that is the equilibrium point. Okay, so now in order to check, just to make sure, we will plug in 3 here, 1,000 here in both, 1,000 and 1,000, and see if we get 3. If we get 3 in both, then that is correct. If we don't, then I have to go back to the drawing board. So negative 0.0015 multiplied by 1,000, and then plus 4.3. I'm sorry, 4.5. If I don't get 3, then I'm in trouble. And then the other one, 0.00075 times 1,000, and plus 2.25. I have to get 3. If I don't get 3, I'm in trouble. Good. So indeed, this is the break-even point. We are willing to purchase 1,000 gallons of gasoline as long as the price per unit is $3. Supply and demand, an equilibrium point. Any questions? Any questions? Is anyone with me?
I'm here. I don't have any questions though.
Okay. So we are ready now to move on to linear systems of 3 variables in 3 equations, 3 variables. Which page am I on? I'm on 10. So 5.2, systems. We call them of 3 by 3. Systems of 3 equations in 3 variables. We're solving systems of 3 by 3. Of course, linear, 3 linear, still. We haven't gotten to nonlinear yet. Okay, so I'm going to copy an example. And I'm going to show you where I'm copying from, of course. So this is page 568. Okay. So I'm going to pick from 5 to 18, and then you pick the next. So let's say I'm going to pick 5. So this is x plus y plus 2z equals 11. x plus y plus 3z equals 14, x plus 2y minus z equals 5. And after this, I'm going to show you another method. Okay, so I have three variables, x, y, and z, and I have three equations. Now, what is the idea? It's the same idea as before, meaning from three equations this time, I have to reduce those three to two equations. And once I get two equations, I choose substitution or elimination. But I have to eliminate one of the variables first, somehow, to get to two equations in two variables. Okay, so we have to choose. So this is equation 1, this is equation 2, and this is equation 3. I have to choose either equation 1 and equation 2 and get rid of x as an example. We may choose y, we may choose z, doesn't matter. So let's say I'm choosing equations 1 and 2 and get rid of x. And then I have to choose two other equations, either 1 or 3 with 3, or 2 with 3, and eliminate the same variable. It must be the same variable. And then I will obtain a system with two variables. Which variables? In this case, in y and z. So let's look at all these and decide which two equations to pick. And let's say, stick with the plan, eliminate x. So if I choose 1 and 2 first, and I want to eliminate x, what should I do? So that's my plan. So part A, I chose equations 1 and 2. I labeled them so we know exactly what we're talking about. I chose equations 1 and 2, and I want to eliminate x. How will I do it? Exactly the same idea, just disregard the fact that we have two more variables in there. It's the same idea as before.
Have to multiply 1 by negative?
Yes, by never exactly. Which one? You choose. It doesn't matter.
We can do the first one.
Excellent. So then I copy again so I know I keep them straight. Negative x, negative y, negative 2z, negative 11. X plus y plus 3z equals 14. We stick with the plan. Yes, I know. In this case, x and y are gone, and z is already done. Because I already have one variable, there is no point in going back and eliminating x from the other two, because I will go back and get rid of z. It happened that my plan was to eliminate x, but because it happened that both x and y went away and I already got z, I'll go back and replace z, and now I have two equations in two variables already. So let's go back with 3, and I have x plus y. 3 times 2 is 6. When I move it to the other side, I get 5. And here I have x plus y. 3 times 3 is 9. When I move it to the other side, of course, I get 5. And now I have to go back to the last one, and I have x plus 2y, and this is 3. When I move it to the other side, I get 8. Negative 3 moved to the other side will be 8. Okay, now, perfect. Let's say I choose these two. I already went from 3 equations in 3 variables to 2 equations in 2 variables. It happened that this is a very simple example. I didn't have to continue with plan B. and choose 1 or 3 and 2 and 3 because I already obtained one of the variables. So now we are back here. We want to eliminate one of the variables. Which one would you like to eliminate? And it doesn't matter.
Let's
Really.
eliminate y.
Okay, if you want to eliminate y, it means that we have to multiply the first equation both sides by -2. So -2x and -2y equals -10, and x plus 2y equals 8. -x, -2. X equals 2. So I have z and I have x. The answer now is an ordered triple. X is 2, z is 3, and now I have to find y. No problem. If x is 2, y must be 3. Is this true? I have no idea. I have no idea. Very simple. So 2, 3, 3. 2, 3, 3. 2, 3, 3. 2, 3, 3. We'll figure it out in a blink. Okay. 2 plus 3 is 5. 2 times 3 is 6. 5 plus 6, yes. 2 plus 3 is 5. 3 times 3 is 9. 5 plus 9, yes. 2 plus 6, 8. 8 minus 3, 5. Yes. Yes, of course. These systems are more involving than the previous 2 by 2. The 3 by 3 they require more work than the 2 by 2. 2 equations in 2 variables. 3 equations in 3 variables is more work, as expected. Okay, before I show you another method, let's choose another.
We do 10.
Let's do 10. So now we have 2x plus 3y plus 7z equals 13. 3x plus 2y minus 5z equals -22. 5x plus 7y minus 3z, -28. Perfect. Okay, let me start a new video because this